Hello everybody, we're now moving into Chapter 3, and Chapter 3 takes us into a really important programming structure. I know at the beginning of the course when we talked about problem solving a little bit, I mentioned that there were three ways that we solve logical problems. There's three patterns basically that we use. One of them is sequence. So we get a sequence of steps, and if you guys remember, we did like some flow charting, and I had you guys come up with like your favorite recipe, for example, and those are always amusing to read to see what food people know how to make, you know. You got everything from like grilled cheese sandwiches to like chili, and that was you, David, right? And some recipes are really simple and some are pretty complicated, but most recipes tend to be do this, do this, do this, do this, do this, eat your food and enjoy, right? Sometimes though, you have conundrums. Okay, so here's one of my conundrums. I was making chocolate chip cookies the other day, right? And I'm like, I don't have enough flour, right? Calls for a cup of flour and I only got like a quarter cup. Uh-oh, right? I'm like, So I start looking around the kitchen and I'm like, well, if I don't have enough flour, then I better figure out what I'm going to do in place of it. Do you guys see what I just said? If, then. So I was at the point where I had to make a decision. One decision was I could run up to the store and buy some more flour. I'm like, heck no, the Packer game's on. I'm not going up to the store. I mean, I could. They were clobbering the Cowboys anyhow, right? But you never. But it got a little exciting towards the end when they started coming back a little bit. But then, you're faced with the decision. Well, it's like I got coconut flour, I got almond flour, and I got gluten-free flour, which the kids hate. Whenever I make anything out of gluten-free flour, because my wife and I do that, they hate it. So I was faced with a decision. All right, a lot of programming kind of involves that kind of situation too. Sometimes, if you go to the gas station and you say, well, if my tank's half empty, I'll fill up. But my tank's only a quarter empty, so I'm not going to, right? Why waste the money right now? Or if my tank's got like barely any gas in it, I better get gas immediately if I can find it, right? So think of all just the terminology I was using. The other thing that you might run into is where you have various situations that you have to contend with. So for example, if you are ordering something online, and you hear the continuous use of the word if, right? Right? It's all about decisions and making selections. If I order something online, and the company is located in the state of Wisconsin, I have to pay sales tax. Think about that, right? So if I order something from Amazon, because they got a facility in Wisconsin now, I got to pay sales tax on it. One of the beauties of ordering things on the internet is that you don't have to pay sales tax. Order from Illinois, they ship it over the border, there's no sales tax, technically. But if they have any sort of a business presence in Wisconsin, then you have to pay sales tax. So I think that's kind of interesting. So one thing that you might do when you're shopping online is think about that exact aspect of like your shopping. You might be able to save, in some cases, a pretty significant amount of money if you're making a $5 purchase, save 10, 20 cents, whatever. You're making a $1,000 purchase, like you're buying a laptop, and the sales tax in your state is like 5, 6, 8, 10%, that's a lot of money. So you should try to buy it out of state and get it shipped just to save the sales tax. I used to buy stuff from like Newegg too. No sales tax. But lately, because I just ordered an M-SATA drive for my son, because he didn't have a credit card yet, And I'm like, what do you mean you got to pay sales? They got a location in Wisconsin now? Darn it. Or a distribution point or something. So I used to love to order from them because I never would pay sales tax. You get pretty much the same price as Amazon, sometimes cheaper. We still bought it from Newegg though, it was a really good deal. All right, so these are the topics we're going to cover in this chapter, but it is these types of decisions that often go into a program that you cannot address with a series of steps. You have to have a point in your code where you're making a decision. So that's what we're going to jump into right away. So let's talk about how this works. Isn't that weird? When I go to the next section, it bumps you to the bottom. Yeah. I don't know why that happens. All right, but I can scroll, so it's okay. I'll live.
Most if statements.
Yeah, and I like the little graphic they have here. They have a graphic of these kids, right? And the kids are standing, and you get to a road. And, I don't know how many times you guys have faced this in your lives, but like you're just walking down the road, and there's a fork in the road. Which way do you go? Well, usually there's signs, right? Chicago, Milwaukee, right? Racine, whatever. But have you ever been walking in the woods and that's happened to you, and you're not sure which way to turn? Yeah. Well, I've done that a few times. Sometimes I made the right turn, sometimes the wrong turn. Look at the moss on the trees to figure if you're going north. But that's basically what an if statement is. It's a fork in the road, and you have to pick one path or the other. Both paths won't work. That's really you can't do both. So, now some, technology textbooks and instructors will call, obviously this author chose to say decision, right? Decision is the next major structure of programming. Some instructors will also call it selection. When I was, classically trained in computer science, I was taught that it was sequence, selection, and then the third structure we're going to learn next chapter is called looping or repetition. Because sometimes you have certain actions you perform over and over again. You get this little example here of elevators. And I think this is really fascinating because this is like totally superstitious, right? Have you guys ever gone into a building and gone to the 13th floor? In fact, they have a whole movie about it. Did you ever see that movie? It's not that great, but it's all right. But it's true. Even to this day, you go into a building, and if they've got like 80 stories, nobody lives on the 13th floor. There is no 13th floor. Actually, the 14th floor is the 13th floor, but they call it 14 because nobody wants to live on it. That's like if you go to the DMV and you get a license plate with 666 on it. Yeah. If you're a Satanist, you're happy. If you're just about anybody else, you're like, that's bad luck, right? I would hand that one back, unless my car was black and I'm making jokes, Halloween jokes. Okay, so they give this as an example, but what they're doing here is they're trying to show you like the way that we would code this. So there's a couple different things that are happening, and one thing I do like that they do is they do bring up the flow charts for this. So if you were flow charting this kind of a condition, you would do what's shown on the screen here. All right, so you'd be going down your flow chart, and you get to this point where it's like, well, is the floor number greater than 13? If it's true, and notice it branches to one side. If it's true, then we subtract one to know the actual floor number. So if I was on the 20th floor, really it's the 19th, but they're calling it 20 because we don't put 13. I think it's a kind of a ridiculous thing, honestly, but it shows you the power of superstition. Okay? If the floor number is not greater than 13th, then the actual floor is just the floor. Okay, so that's the visual of the problem solving. So if you were flow charting this, and remember, a lot of programmers do go through the process of flow charting stuff out so they can figure out all their logic. It also helps you to figure out how to code it. It'd be a shortcut. And this is a pretty simple one, right? Because there's one decision being made and two paths you can take. But sometimes one decision leads to the next. So, if I had enough money, I would buy the Cadillac. If I still had enough money, I might get the deluxe package, And you can keep kind of branching off of that. We'll learn that in just a little bit. If you convert that to code in Python, this is how we write it in Python. Now, I know some of you have had other languages, and most languages are similar, but Python has a couple of unique quirks to it that make it a little different. So they begin by actually using the word if. That's the key word that drives the whole thing. Okay, so that is how we make a decision. We say if. Then we will have a decision or a value or something we're checking. So floor being greater than 13 is what we're checking. So depending on the result of that, if that statement is true, okay? See, it's not being set equivalent to anything. We're just checking. So if I floor was equal to 15, and I put it into floor, 15 is greater than 13. Therefore, or then, and that they do that in Python by doing a colon. I think that's kind of odd. Okay, but there is actually a little bit of a history with that. Then you perform these statements. Now notice that the statement is indented. And in Python, that's critical. Because in Python, we don't have curly brackets like we do in some languages. So I know some of you have learned like Java or are learning Java already and maybe have covered this stuff. And in Java, you're supposed to put curly brackets around it if it's more than one statement, right? And I'm kind of whispering that because in Java you can actually omit the curly brackets, but then a good teacher will tell you should always put them in, right? Remember that, David? But in Python you don't use curly brackets, so you have to indent your statement. So anything that happens indented after that colon, if it's true, that's what we will do. And then we also have the possibility of doing the false and having a statement attached to the false. So if it's not greater than 13, let's say the number is 5, the first condition would be untrue, so we don't execute it. Then we go to the else, where we execute that statement. So if the statement's not true, we go to the else part and we execute that statement. And it's kind of a decision tree. It's the either or, true or false, black and white. You're picking one over the other. All right. Let's move on. It's also possible that you do this, right? So if the actual floor, think about the logic here. If the actual floor, you type it in, you store it in a variable, let's say that actual floor is 15. Do I really need to have an else? Not really. If it's already 15, why do I need to subtract 1? I don't need to. I can just leave it alone. So sometimes you do if statements and there is no else. You just move on. There does not have to be an else. Only if it's above 13 will I subtract a floor. Make sense? Either approach will give you the right answer, but one is actually more logical. This one is actually more logical in this scenario because you don't need to do any alterations. All right, so that's something you think about. All right, they have this nice little graphic here about if statements, and I think this is a nice one maybe to study for your midterm, hint, hint, hint. All right, and some of the things that you have to do. So they talk about, if, the keywords if and else. The colon indicates that there's a statement that follows. The statements that follow either one of these must be indented. And not only that, but the if and the else have to be aligned with each other, and then the substatements have to be aligned with each other. And Python's a little quirky this way. Other languages don't enforce that. You can kind of put stuff wherever you want and it still works. Python, because there are no semicolons and no curly brackets around it, the indent tells you that it's a separate statement. So that I think that's a pretty important thing. All right. They actually have a little program here. I'm not going to run it, but if you guys are really so inclined. All right. The other thing that can happen is if, of course, once again, if you have a situation that resolves to true, then you're going to have a bunch of statements that happen after that truth. So it might not just be one thing that happens. If something's true, then you might have a whole bunch of stuff to do. Okay? If the grass is taller than 10 inches tall, I have to mow it. Well, what does that mean? Well, I have to get gas. I have to fire up the mower. Empty the lawn, the lawn clippings. I gotta get the rocks off the lawn, the twigs off the lawn, and the football off the lawn, whatever's sitting on your lawn. Move the lawn chair. There's a bunch of stuff you have to do. Sometimes it's not just one statement. That's the point here. So that's called a compound statement. So sometimes, if something is true, there's a bunch of things you have to do, not just one. So in this case, they have the example: if the total sales are above 100, then you can figure out your discount. Subtract the discount from the total sales, and then you can print out the output. Right? This one doesn't have an else attached to it, but it might. Maybe the else to this one would be, you don't get a discount, sorry.
You have a discount at your supermarket whereby buy X amount, like 5 pieces of this, get a discount on that. So if there's,
Right. Like,
you know,
buy 2, get 1 free.
Yeah.
Right, but you still got to buy 2.
yeah.
That's actually a pretty good example, David. All right, so they have some examples here, and I would always encourage you guys to play with those. I'm not going to waste the time in class. All right, so they want to point out some things here, and because we are now covering decision statements, we are also forced to do indenting with our code in order to make Python read it correctly. And this is critical in Python. Now, those of you that may have coded before know that there's like this little battle in coding, in coding worlds, I guess, or geeks or whatever. Some geeks will say, I always use spaces to indent, and some geeks will say, I always tab to indent. And you know what?
What kind of tab? A hard tab or a...
Yeah. Did you guys watch that show Silicon Valley on HBO? They have that. There's this guy, like, he's a total geek, and he finally gets a girlfriend, and then they break up because she insisted on using spaces, and he was a tab guy. That's it. That's a deal breaker. So that's the kind of silly stuff that geeks joke about. The truth is, some IDEs might automatically indent for you if you have an if statement, just so you know that. Regardless of whether it happens automatically or not, or if you choose spaces or tabs, be consistent in what you do, and remember that you have to do this kind of formatting in order for it to be valid. So this one shows kind of a compound if statement. So what it's showing is the if with compound statements, the else with compound statements, including another if inside the else, which also has to be indented. So that's how you kind of differentiate blocks of code in Python, is through the indenting. Other traditional languages typically will use curly brackets to do that. So that's a pretty important thing, and I think that's a good thing to know. Another little tip that they give here, and I like that the author does this, because this is the kind of stuff that, like if the textbook doesn't talk about it, I usually end up talking about it anyhow because I want to make sure people know it. But take a look at this actual example here. So here they have the if-else with the floors, right? And so the thinking is, okay, if the floor is greater than 13, subtract 1, and then tell the user what it is. All right? Otherwise, don't subtract 1 and tell the user what it is. But there's a duplication there because the print statement is listed twice. It's silly. We're going to end up doing the same action either way. What makes more sense is to pull that statement out, because either way you're going to tell them, right? So you don't have to have it inside the if statement. Right? This is common sense kind of thing. Cuts down the amount of code that you write, which makes your program more efficient and run faster. And you know what? Logically, it's a whole lot smarter too. And these are the kinds of things you see as a programmer. So you might actually start out by writing your code like up above, and then it'll dawn on you, oh, I don't need to do that. I can just do it after and just save a line of code. And you'll see those efficiencies as you get better at programming. The other thing that's kind of interesting is Python has this, I forget I'm trying to remember if they're called these like ternary operators, or they have like this like modified if statement that's available. We kind of looked at it earlier in the book. And a lot of languages are doing this now, where you can do an if statement in one line. And Python also has a form for doing it, but their form for doing it is shown right here. So instead of going, if this is true, then do this, else do that, you can put it in one line by going like this. This is the value if this condition is true. Otherwise, this is the value. And then if you look at it spelled out, so it's the same code we were looking at before. So we're subtracting 1 from the floor if the floor is greater than 13. Otherwise, it's just the floor. That might be a little uncomfortable for you at first. Okay? But in some circumstances in programming, and I'm seeing this in all the languages have this like hot wire approach to doing if statements. If you only have one single statement or one single value that you're applying, this is a really quick and convenient way to do an if statement without writing a whole block of code. So you might not feel comfortable doing that initially, but this line here is equivalent to this whole 4 lines of code. I might pepper in a question like this on the test. I'm just saying. So that's one that you might want to flag. Okay. They actually showed an example here, and we actually did, I don't know if you guys remember that, but way early on we had a little example of this. And so what they're doing here is they're putting that whole if statement. So actual floor, and then the floor minus 1 if it's greater than 13, otherwise it's floor. So that determines which value we're passing. That's all it's doing. Okay, you guys comfy with that? Yes, Mr.
Lower
Kiddes.
than what, the math lib?
No, not the math library. Relative to the 13th floor.
Oh.
Yeah, we're still talking about the floors. All right. Now, I think it's interesting because you kind of learned about the if statement first, and then they talk about relational operators. And most of the programming textbooks that I've read and learned from in my day tend to do it the other way around. They usually give you the relational operators first. But I think the author is kind of like figuring out, you guys know what a greater than symbol is, right? Okay, thank you very much. So I think it's actually an okay approach. But now they're coming back and they're talking about the relational operators, because sometimes in an if statement, you're not just checking to see if something is greater than. Sometimes you're checking other things. So the different relational operators that we have available to us in Python are in this table right here. So in this table, you can see they do a comparison between what you learn in your math class and how a programming language does it, like Python. Python fortunately uses the same language standard for relational operators that most every language does, thank goodness. I always hated teaching Visual Basic because Visual Basic totally did some things completely goofy. I don't know if you guys ever learned that language or not, but like not equals was like greater than and less than put together. It was just, yeah, not good. But here, the symbols are pretty close to what the math equivalents are. So there's greater than or equal to, less than or equal to. And then we got the equal, which stands for equal, right? Because you got to remember in programming, see that right down here?
Yeah.
And they have the example. That doesn't check to see if floor is equal to 13. That makes floor equal to 13. Single equal sign is an assignment statement. That's a rule in every language. So there's equal, which means now I can check. If floor is equivalent to, and that's the way I think of it in my head, to 13, then this is true. So sometimes you're not checking for greater than or less than, sometimes you're checking for equivalency or not equivalency. And the way that you do the not equivalency is an exclamation in front of the equal sign. So if something is not equal, okay, then it's true, and then we trigger the condition. All right. The fascinating thing is you can actually use that equivalency thing on strings too. Right? So for example, like when you log into a system, right, to authorize yourself, they check your username and they check your password. And they make sure that those are equivalent to the string that they have stored, right? Whatever that happens to be. And so they give the example here, if name1 equals name2, okay, the strings are identical. Or you can say if name1 does not equal name2, the strings are not identical. Okay? So just some examples. They have these little breakouts. And notice what it says. For two strings to be equal, they must be of the same length and contain the same sequence of characters. So in this case, the one I just zoomed in on, they're the same. Good, we're good, right? If only one character is different, the two strings will not be equal. Well, obviously, if it's John and Jane, that's different, right? Right. They're the same length, though.
The ASCII encoding's different for uppercase and lowercase.
It is. Uppercase letters are different than lowercase letters. So if I do John Wayne and John Wayne, but John Wayne here is spelled with a lowercase w, wrong answer, not the same. Not the same. You guys got that? And that's a pretty important one. All right. So this is kind of fun, in my mind, this is kind of fun, is to look at tables like this and figure out if things are true or false. So the first one is 3 less than or equal to 4. Is that true? It's less than, so it's true. Is 3 equal or less than? Well, that's not right. That's not even stated correctly. Yeah. The less than sign has to come first. Yeah. See the difference there? All right. Is 3 greater than 4? No. False. Is 4 less than 4? No. False. Is 4 less than or equal to 4? True. True. Yeah, because the equal applies. Is 3 equivalent to 5 minus 2?
Yes.
Absolutely, right? Because 5 minus 2 is 3. Is 3 not equal to 5 minus 1?
Yes.
It is not, because 5 minus 1 is 4, so it is not equal to 3. So that's true. See, you get that logic stuff kind of going in your head. And I'll tell you what, it's not uncommon to screw these up when you're setting them up initially. Experienced programmers screw them up all the time too. So don't feel bad. If you mess up, remember it's just code, undo, try it again, and get it to work. All right? How about this one? 3 equals 6 divided by 2. Well, that wouldn't work anyhow, right? Because 3 can't be a variable name. Because the single equal sign is an assignment statement. So it specs on this side, it should be a variable name. If you want to check to see if these were equivalent, it's 3 equals 6 divided by 2, which would be true. All right. 1.0 divided by 3.0, equivalent to 0.3. Yeah, and this is what's going to happen. So they have a whole section about this. They wouldn't exactly be equivalent. Yeah, and that's kind of a weird one to wrap your head around. Because when you do these weird floating point math things, you get these like trailing values that don't always match up. And I thought they did a really nice job in chapter 2 when they talked about the old Pentium chip and how it was broken. I remember those days. You know? Yeah, the Pentium chip when it first came out couldn't do math properly. That's a little bit of a problem for a computer that's built on doing math, you know. Did I tell you guys that's all computers know how to do is add? I told you that, right? Yeah, that's all computers know how to do is add. If you can't do math, you got a bad computer. All right. How about this one? The string 10 greater than 5, you can't compare numbers and strings. Sorry, folks. If you convert it first to a number, which you can do, then you can compare, but you have to do the conversion first. Okay. All right, so they have a bunch of examples here. I'm not going to run through those because we're going to actually do exercises. All right. All right, what about comparing floating point numbers? So this is a little bit weird. And I want you to read this really carefully and understand what's going on here so there's no misconceptions. It says, floating point numbers have only a limited precision and calculations can introduce round-off errors. And we kind of have seen a little bit of this already. So it says you must take these inevitable round-offs into account when comparing floating point numbers. For example, the following code multiplies the square root of 2 by itself. Right? So if you take the square root of 2 and then multiply those together, you're supposed to get 2 again. Right? Well, you actually get an error, believe it or not, if you actually run this equation, because what will happen is it'll do this little round off, so like, I don't know, 30 digits in or whatever, it throws a 4 in. I mean, if you rounded it, it's fine. But if you're trying to be really precise, that's a little bit of a problem. So the questions you should start asking yourself is then like, well, how the heck did they land the man on the moon then? You know, because the math needs to be really precise. They use, you know, there's other programming languages that they use, and there's other libraries they pull in to make the math more precise. That's what happened. So some programming languages will have not just floats and ints. They'll have like 10 or 20 different number types, each with varying degrees of precision to allow for real precise math. So now, does that mean that Python can't be used for precise math? It absolutely can. But no matter what the language is, these kind of errors happen, just a matter at which point they happen. Python, with its default data types, will have these rounding errors at approximately that position. I think it gets up to like a few billion, or, you know, number size before it starts to break a little bit, right? Right. So there are ways to actually kind of fix this, and this is when you get, and this is, okay, it's 10 to the negative 14th power or 10 to the 14th power where that comes in. This not really, I'm not going to give you guys any like problems that go out that far, that many decimal places, so don't freak out to it. It's just something that's good to know. Yeah, exactly. Now, the funny thing is, you know, we can compare strings to see if they're the same, right? John Wayne, John Wayne. But can I like see if a string is less than the other string? Sure, if I'm trying to alphabetize them, right? Apple would be less than baseball, right? And of course, if you had words that had multiple letters that were the same at the front, there's different values for each letter, so then it would start checking them individually. So you can actually compare to alphabetized letters. Sometimes, you know, if you want to make sure that you're really properly alphabetizing, though, it is suggested that you convert either to all uppercase or all lowercase before you do the comparisons. And, you know, there's a lot of little ramifications. We're not really too worried about this, although it is kind of a common programming problem. And I'm sure, like, if you have like Christian or Christopher or Wendy for Java, and I'm just shooting it out there, you guys, that you'll probably do a couple of alphabetization programming things in Java too. I usually do. All right. Now they also have this like how-to section here, and I'm not going to read through this, but I do really strongly suggest that you do read this section. I think it's pretty well written. So you can start thinking about how you might actually implement an if statement. So, you know, decide basically what you're going to do. And my real strong suggestion is to pseudocode or flowchart out what you're about to do to see if it even makes logical sense before you try to code it. If you're a more experienced programmer, you can kind of skip that step sometimes. But I still find, even with all this, you know, the code that I've written, I still often like sketch things out, at least on a piece of paper. You know, oh yeah, that'll work. You know, just for example. All right. Now there's a few of these like how-to samples here, and I'm just going to let you guys kind of contend with those on your own. So then I want to get over to section 3.3, where we start talking about nested branches. All right. So what they mean by nested branches is this. It's a decision statement inside of a decision statement. Sometimes you make a decision, you take a certain path, and it just leads to more forks in the road. Right? Just how it is. You know, so this will give you an example of that. So they use this tax rate table, and you know what? This is kind of how complicated taxes are. So it says if your status is single, and if the taxable income is at most $32,000, here's your tax. If it's over $32,000, then you pay a certain amount plus 25%. I'll tell you what, when you guys get out into the work world and you start like actually making some money, and then you finally start making some real money, and then you start seeing what the government starts taking out of your check, and you go, oh my God, I wish I wasn't making this much money. Or working under the table, maybe.
How do you buy gold?
Well, if you have deductions, that's where you kind of slide a little bit. Then, if you're married and you have income that's taxable, of course, you jump into a different tax bracket, right? So that sometimes helps. So like if you have more income, but you're not living on your own and your wife doesn't work, it kind of like balances out a little bit. So you still have to pay the taxes, but sometimes it's in your benefit. So that, and I'm not sure if this is actually what the federal tax rates are. I would assume not, because I know that they've recently changed. But the way that it's traditionally been set up in the United States with taxes is, the more money you make, the more taxes you're supposed to pay. But what happens is the more money you make, the more tax write-offs you have too, right? And a lot of those people get business income, and like you get these big giant corporations that on paper don't make any profit ever and never pay taxes. Isn't that bizarre? But that's how all big corporations operate. When I ran a business and I had a corporation, I ran it that way too. Because otherwise what would happen is whatever the business was paying me, I'd have to pay taxes on it. And then if my business made a profit, I'd have to pay taxes on that too. So some people think that's unfair. And the truth is, I think that, if you make money, chip in. But the bad thing is that people that make money can hire the right lawyers and know all the loopholes to not chip in. So there's kind of this balancing act. And I'm not playing politics here, I'm just kind of like, just telling you guys. So, and that is, the single and married, or filing jointly thing is a discussion that my wife and I have been having over the years too. Because she's basically been a stay-at-home mom, right? So she hasn't had income. But it doesn't mean that there's not like a value, so you got to sometimes compare like which way is better to see which tax return is bigger or which way you pay less taxes. It's not, anything wrong, it's just what people do. Now sometimes, what they're trying to point out here is sometimes you have multiple decisions to make. So here's an example. So first they say, are you single? Okay. So if that's true, then you have to check to see, is your income less than or equal to $32,000? If that's true, it gives you your tax bracket. If it's false, meaning you're making over $32,000, then you go into the 25% tax bracket. Okay. Let's say you're single. You're not single. What does that imply? You're married, right? So notice I don't have to have a decision for married because you're either single or you're not. Right? So I don't have to put in a second one to see if you're married. The false of single implies that you're married. See, if you would look at the table up above, you would say, well, if you're married and, well, you don't have to write that in because if you're not single, then you must be married. So the false branch covers married, and then they check the income there. So are you less than 64 or greater, right? And then you come up with your various tax brackets. So, but that is still called branching because we have the first if statement, which checks if you're single, and then following it, we have a secondary one, regardless of which path you're going on. Okay, so those are called nested statements. So if you were to write this out, so notice how they're doing it here. Marital status. Please enter S for single or M for married. When they write it out, notice that they're kind of flipping it here. So notice what they're doing. They're saying if marital status equals S. Or are they flipping? No, that's just the same thing. So if you're single, then you go ahead and you check your income, if you're below, or if you're above. So this code here is the expansion of what we saw up above as the flow chart. And this is, this author's calling it nested branches. In most languages we call it nested if statements or nested selection or decision statements. And that's unfortunately how life is, right? Sometimes, if you choose to go this way, you still have more decisions to make. It's all about getting to the right answer, though. And any problem that you have laid out, where you have the information about how to figure it out, there's always a way to get to it. And one of the challenges of a programmer, before you go to write the code, you might be able to just jump in and write this code, but I'm thinking that more often than not, you probably would get something like this in a document or in a piece of information or just from what somebody told you, and then you start sketching it out, either in pseudocode. I think decision statements are easier with flowcharts, though. Then once you have the flowchart, then it's really easy to go and write the code because it's kind of already written when you have the flowchart, right? So that's kind of the approach, folks. You want to play with that, go for it. These exercises are actually pretty fun. And I hope you guys, with the ebook, actually figure that out. All right. All right. They talk about this process of hand tracing. Please read that. I'm not going to cover it here. I think that's a nice little written little piece. They also have some little side stories here. Go ahead and read those. That's all about luggage. I remember in the old days, my dad used to fly a lot. He was a sales guy, I couldn't tell you how many times he would lose a piece of luggage. It was a lot. To the point where he stopped taking big suitcases and only took carry-ons. I don't know if you guys do that, but I'm always paranoid too. I go on a plane, it's like if I can't fit it in a tiny little bag, I'm not even taking it. The last thing you want is your suitcase to end up in a different country or state or something. All right. Now, the next branch here, if you want to think of it that way, is what we call multiple alternatives. That's what the author is calling it. So for example, if you're writing an if statement, all right, maybe that's not a good example. I'm trying to think of one in my head. Okay, so here's a good example. You go to a website and you're about to check out because you're buying a product, and then they want to figure out your shipping, right? And then you might be like, what state do you live in, or what's your zip code, right? And based upon your state and or zip code, they figure out what your shipping rate is, so if you're looking in different zones for shipping. Or if you are filling out a form, perhaps, where you have a little state drop-down box, and there's 50 options, right? And depending on which option you choose, there might be different things that happen. So this is what I would call a multiple alternative. I want you to think about this. If there's a different shipping rate for every state, do you have to go in there, write code that says, if the person lives in Wisconsin, if the person lives in Illinois, if the person... Right. There's actually a shortcut way to do it. You could do it like that. You could actually do it like that, right? But those are called multiple alternatives, right? So they give an example of the Richter scale, and they're saying that, if it's under 4.5, usually nothing bad happens. If it gets up to 4.5, if you got a bad building, it's going to break. If you get up to a 6, many buildings will be broken. 7, many buildings destroyed. You get up to 8, almost everything is just toast. Okay, so that's multiple different values. So what they're showing here in this little graphic, and I'm going to do the zoom. Oh, that was the zoom. All right, that's not much of a zoom. Is they're showing basically how you would go through and check each one of those. And notice how this is happening now. It's basically a series of ifs. And if it's a false, it moves on to the next if, to the next if, to the next if. If it hits the condition true, it does whatever the statement is and then drops out. So hard to see on some of the screens in the classroom, but there actually are lines that come down here off of these. And then you have whatever your results are. So in terms of maybe coding something like this, you could do something like this. This is one option. And I actually, given what they gave as information, I'm not necessarily sure that the else's are necessary, although logically they're true. So if the Richter scale is 8.0 or greater, not very likely, right? So the else is going to catch, and then you ask another question. If it's this, another else. If it's this, another else. If it's this, another else. And that gets a little complicated and watered down. You can totally do that. And you know what? Logically it works. But what they're going to show you here is there's a different way to do it. And that is what we call an else if. And in this language, it's an elif. I don't know why. But it's combining the else if, so you don't have to do all that nesting, but it's functionally the same. So the first condition didn't catch, so let's check the second one, the next one, the next one. And that's actually a cleaner way to do it too. Instead of having to worry about how you're indenting it all, because it's really easy to get screwed up, this is a nice clean way to accomplish it. All right. They have some tips here, and this is kind of what I would actually do in this code, because the truth is, the if statements really here are all kind of independent in my mind. I wouldn't necessarily write it as else ifs. I'm just putting it out there, because the condition's either going to hit or not. Where it might not be eloquent is if there's stuff in between. Because think about this. If I'm checking a condition that says the Richter is greater than 7, right? Okay. So I might trigger that true, but wouldn't this one also be true maybe? You could trigger two of them being true, right? So that's why you do the else if, is to eliminate possibilities. So that's one thing you gotta watch. All right. All right, so folks, we are out of time here. What I would like you to do for next week is finish reading this chapter. I'm going to lecture on the little bits that we have left. And believe it or not, we've already hit most of the important parts of the chapter. It's going to be enough to get you started on the homework. We will work through the homework next time in class, cover the remaining topics, and then get prepared for the midterm. All right? So I'll catch you all next week.